Hello, Canada. I'm Sarah Haverstick, Senior Manager of Safety Advocacy and Consumer Care for Even Flow. I am so sorry I can't be with you. I promise I am trying so hard to get up there for one of these conferences, so hopefully next year. But for today, I was asked to share a little bit about some of the work that we do. And this presentation, we're going to talk about testing we do outside of sled testing. So I think generally technicians have a pretty strong understanding that we test our products in a crash testing lab environment. There's a lot of other stuff that we do outside of crash testing. So that's what I'm going to cover today. So, in terms of objectives, we're going to talk about the role of product integrity testing for car seats. We're going to talk about the federal motor vehicle safety standards and other standards that are related to car seats and their product integrity testing requirements. And then we're going to talk about our own internal product integrity testing standards. And I should say, I am going through this presentation sort of with a US lens referencing the federal motor vehicle safety standards. A lot of these same requirements exist in the CMVSS as well. And generally, all of our products are, if we're selling them in Canada, there's something that are also compliant in the United States. And if anything, we do a few additional things to meet other CMVSS requirements, but they would all be going through the same US requirements too. So just kind of general statement there. Another just general disclaimer for legal purposes. The information that I'm going to talk about today is not an exhaustive review of everything that we do in terms of product integrity testing. It does not represent all of the testing that we do for Even Flow products. We do not have time to go through everything that is done in this session, but additionally, some of that's proprietary information that we wouldn't be able to share in, mixed company, so shall we say. So just for background, to define some of these terms I'm going to talk about. Product integrity, generally, we have some company responsibilities here. So we want to make sure that our legal and internal corporate requirements are being met. So any of these regulatory things that we have to do, we need to make sure that we are doing all of those things. Really importantly, we want to make sure that the customer or that end consumer is satisfied with their product. So that means not only is it going to perform from a crash perspective, but general use and durability. We want to make sure that the product functions always as intended. And then we certainly review product returns to validate or verify any complaints that we do end up getting from consumers. With new products, we test products throughout the development process. So as we are designing a new car seat, we are going to run product integrity testing alongside the crash testing that we're doing throughout the development process. Certainly, we are going to retest after we make any significant changes to that product that is still in development. And we will run every single solitary test again during our production pilot, which is the kind of that final round of testing before we go into production. If we're working on a project like that is already out in the world, so I'll use the Revolve 360 as an example. It's a product that's already out there. We will still do testing. So we may still run some changes to that product. So if we make a change to that product and we're doing this just as a running change, we are certainly going to run appropriate testing before we go forward with any changes. And then just generally, we'll pull random samples from production and do both crash testing and product integrity testing from time to time, just to ensure that all of our production is conforming to the specs that we expect. So when we do our product integrity testing, this can be done virtually or it can be done with real world actual tests and samples. So the virtual analysis is often where we start. It helps us to save some time and a lot of money. So from the beginning throughout our development process, we are creating a CAD model of this product, which allows us to then do these kinds of virtual tests. What you see here is a drop test And so you can see kind of one side, the side of that car seat that's hitting the ground first. You can see some of those colors representing the stress that's being placed on the car seat in that area. So it helps us when we do these virtual analyses to potentially find issues with that product before we've invested capital into the tooling and into really moving forward with that specific design. However, virtual is still just virtual. It's not the real product in the real world. So we will always conduct real world testing. It is much more expensive. It is much more time consuming. So to test that product in the real world space, it means we've already invested a whole lot of money into this project because we've already been through the tooling process. So we already have real samples. So we've already made big investments and now we have to test lots. So it's not just you pull one product out to test. It's generally we're testing in batches and we have multiple products. So we're building multiple seats out so that we can run all of this testing. It is very time consuming. We're going to talk about some specific examples of tests as we go. But we need to conduct that real world test to ensure compliance with production models of our car seat. So, and once we have that real world test, we're able to validate that virtual analysis too. So lots of benefits there. We can continue to make our virtual model stronger so that in the future, any testing, any potential future changes we want to make, we can again go back through starting with that virtual analysis with an even stronger virtual model. Some of the testing I'm going to talk about today is required, which, it's mandatory. Often that comes in the form of some type of legislation that has been enforced. So in this case, a lot of what I'm going to talk about is enforced via the Federal Motor Vehicle Safety Standards, or in Canada, the Canadian Motor Vehicle Safety Standards. Some of the testing I'm going to talk about today, actually a good bit of it, is voluntary. So it's stuff that we choose to test, often for that consumer satisfaction. Again, at the end of the day, it doesn't matter how well this car seat might perform in a test. If it breaks easily in a specific condition that the consumer is going to interact with on a regular basis, and we're going to get complaints about it, that is not going to end well for us. We're going to see lots of negative on social and in reviews, and that's not what we want, right? We always want to create a product that consumers are going to be very happy with, that is going to be robust, that is going to do what it needs to do in crash testing, but under just general use conditions, it's going to hold up. So a lot of the testing that we do, you'll see it's cycle testing, it's engaging with moving parts over and over and over and over and over again, because that's how a consumer ultimately is going to use the product, and we want to make sure that the consumer is happy with that product. So a lot of that testing is stuff within our own internal quality spec or other specs that we've decided to pull in, even though they aren't actually required. And then as we go through this, we're going to see some tests that are done manually. So that means it's conducted by an operator. There's a person that is actually doing something to make this test happen. Benefit there is that person can give us feedback, like qualitative feedback on product use. If it broke at some point, they can give some indication of how the product broke, what was happening in that moment. But, people are fallible, and maybe that person wasn't consistently applying pressure throughout the test or whatever their test might have been. Maybe they were performing a function, even if just that one time they performed it improperly, and that's what led to the failure. So there's those things to consider. And plus, a single operator, is going to take more time and is going to be more expensive. Some of our testing is automated. So that means a machine or a fixture is actually what's running through the test. And then generally that test is very consistent throughout that cycle. So if we're doing some kind of life cycle testing, meaning we are testing as many times as we think that feature might be used in the whole life of that product, we're talking about potentially thousands and thousands of repetitive tests that really isn't feasible for a human to do. So in this case, if we have an automated test, it can happen consistently throughout and be operating 3 full days in a row if necessary to meet the number of cycles that we require. In that situation, depending on the automated test and that fixture, if and when there is a breakage, we certainly aren't going to get any qualitative feedback. And depending on the test fixture, we might not know exactly when that breakage happened, or again, qualitatively, what was happening when that breakage occurred. So that's just a little bit of background there on some of the types and terminology and things that we're going to talk about moving forward. A little bit of background now on what some of these test standards are and who are some of these regulatory authorities. And again, starting with the FMVSS, the CMVSS would be very similar here. There's a lot of regulatory information in those motor vehicle safety standards. And I would say that this is now actually really simple, what I'm showing on screen, in comparison to the complexity that, at least in the United States, is our current motor vehicle safety standard, with all of these updates coming with side impact testing and with updating our existing standard to a new standard. So there's a lot happening in the regulatory space, but it's not an excuse. Our team has to understand all of these things, where they exist now, where they will be existing, and what new things we need to be able to do and how our products need to be able to perform. And the same goes for Canada. We have to then understand what are those differences between what is required in the United States versus what is additionally required in Canada. So all of these things come into play. And, generally we think about the motor vehicle safety standards really as a performance standard and not a design standard, meaning this is a set of rules by which we have to operate and our product has to be able to perform. But generally, it isn't informing us how we have to design the product. So it leaves open for brands to, innovate how we get to that end goal. And here, we were pulling out both the car seat standard, the restraints within the vehicle, so seat belts, webbing, buckles, etc. And then 302 for us is that flammability standard, that flammability surfaces inside of that vehicle. But often I think we think about all of these things in terms of how is that car seat performing in a crash. And today we're going to talk more about how do other functions of that car seat perform generally. And we're going to start with something simple, the buckle, and specifically the buckle release pressure. And why do we measure the buckle release pressure? Well, we can't have a buckle that is so easy to open that a child would just be able to push and pop themselves out of that harness system. But we also can't have a buckle that is so difficult to open that a consumer, and including a consumer with more limited hand strength, would not be able to also open that buckle when necessary. So there's some specific parameters here, and we test both brand new buckles, and you can see no less than 40 newtons of force is what it should be able to release with, or no more than 62 newtons. So we've defined the minimum and the maximum there. And for those here that aren't engineers like myself, I am not an engineer, newtons mean like nothing to me. So for a little bit of, reference here, 40 newtons is about 9 pounds of force. 62 newtons is 14 pounds of force. So just to give your brain a little bit more reference. We also have to test that release after a crash test. And that, in that case, we have a little bit more room, and that's 16 pounds of force is that 71 newtons. We also the motor vehicle safety standards also regulate the minimum surface area of that push button for release. So you got to be able to get your finger in there and have enough surface that you can actually squeeze and open that. So that is required in the regulation as well. The regulation also has information about webbing, and specifically the width of the webbing. Now, most brands, we're not manufacturing our own webbing. That is a component that we are purchasing from a third-party supplier. So generally, the supplier of the webbing is the one that's doing a lot of these tests. But in terms of width, the webbing that's going to be in contact with the child has to be at least 1.5 inches wide. So that's your harness webbing, right? That part that's going to touch the child. And why do we need it to be 1.5 inches wide? Well, think about what we learned back in certification course. What is the purpose of that car seat, and how is it helping to protect the child? Well, it's helping them to spread out the crash forces over a larger area of their body. And part of that spreading out of the crash forces is that webbing being in contact with the child's body. If the webbing was very thin, it would be putting more concentrated pressure in certain areas, again, where it's in contact with that child's body, and we don't want that. So that minimum width is 1.5 inches wide. And that's on screen. What you see here on the left-hand side at exactly 1.5 inches wide is a piece of harness webbing. In the center, I think obviously is a lower anchor strap, which is a little bit more narrow. And then narrowest of all is that CFA tail. So the central front adjuster, you can see here attached to the splitter plate. That's the piece that you're going to pull to tighten or loosen the harness webbing. And that is the most thin. It's not going to be in contact with that child at all. So we test this after conditioning too. So with specific humidity and temperature requirements, we also test this under tension with about 5 pounds of force to make sure we maintain that 1.5 inch width of webbing throughout. Importantly, we also test the breaking strength of the webbing. And why do we do that? Because what is the purpose of the webbing but to hold the child in that car seat, and specifically to hold them in under dynamic force in the midst of a crash situation. So we have to make sure that webbing is strong enough and maintains its integrity in that crash situation. So again, we do this with new webbing, and here you can see some really big references here. So new webbing has to be able to maintain its integrity with more than 15,000 newtons if it's attaching the car seat to the vehicle. So think about your lower anchor strap that I just showed you a second ago, or 11,000 newtons for webbing that secures the child to the car seat. So that harness webbing. So a little bit more force has to be applied potentially in that crash with holding everything, the whole component together, which is your lower anchor strap, and then a little less force on just the webbing that's holding the child in that car seat. These are really big numbers that really don't mean anything to my non-engineering brain. So to give you a frame of reference, that's why you can see some random animals on here. They're not random at all. 15,000 newtons is roughly 3,372 pounds of force, which is roughly equivalent to an adult female hippo. So what we're saying here is you should be able to take that lower anchor webbing, wrap it around our little hippo friend here, and lift her off the ground without breaking the webbing. Additionally, then, our 11,000 newtons is approximately 2,472 pounds of force, which is roughly equivalent to an adult female giraffe. Same story. You could take your harness webbing here, wrap it around our giraffe friend, lift her off of the ground, and that webbing would remain intact. So all of this webbing, very, very strong because it needs to be strong. But webbing doesn't stay new and perfect forever. So we also, good, that's running. We also have to test it after some conditioning. And the very boring video on the right that I just made sure is working because it's hard to tell, there is something actually happening. This is what that test looks like. So you'll see that happening over on the right-hand side of the screen. We have to condition this webbing because, again, webbing isn't new forever. So we also test with abrading the webbing. So that means we're damaging the fibers. And then again, it has to perform with no less than 75% of the new webbing strength. We expose it to the light of a carbon arc, i.e. UV rays, because where does this car seat sit but in a vehicle exposed to UV rays? And in that case, it has to perform with no less than 60% of the new webbing strength. And then we expose it to microorganisms, i.e. mildew and rot. And again, you can see there no less than 85% of the webbing strength. Interestingly, that is burying this thing in the ground for 2 weeks and then taking it out and doing the test that you just saw. So you just saw, the big aha moment of this test. It is very slowly pulling this webbing until it breaks, and then we're able to measure that force required. Flammability testing, this is always a hot button topic. We test all pads, soft goods. We test everything individually down to the individual thread. And then we have to test everything once the pad is fully assembled. Webbing is also tested for flammability. That again is often done by the webbing supplier, and then any other surfaces that would be contacted by the child. Again, we do this generally all the time. So throughout production or throughout development before launch, we'll be doing this testing to confirm that we meet the specs. And then if we make any changes, if we decide to move to a new fabric, we would again do that testing. We do this by exposing that product to a flame with a specified height of flame for a specific period of time. So we have a little testing chamber, and you're able to expose that material at that point, again, holding it there for a specific period of time. We have to then wait until the flame burns out or that fire ultimately ends. And while that's happening, we're measuring how quickly the flame is spreading. That product or the item is basically held horizontal in this chamber. And again, we're measuring the rate of flame spread. So what we don't want to see is everything to flash up and burn quickly. So we want to be able to give the child a chance to be able to get out of the seat in a fire situation. There is, as you would imagine, a specified rate of flame spread, which is 102 millimeters per minute. That's what's allowed, which is 0.004 miles per hour. So that's what we're measuring in that test. Another one of these organizations that has requirements for us is called ASTM International. So ASTM is a standards making authority. They have professional members that serve on technical committees. So these are really the subject matter experts, and they then create or author standards. The thing with ASTM, though, is they have no role in requiring or enforcing compliance with their standards. They are essentially just those subject matter experts that are sitting in the room to say, this is what we should do, and this is what makes the most sense in this specific industry. However, their standards are then referenced and become mandatory by other people referencing them. So you could have a corporation like Walmart saying, I want all of my products that are coming in this industry or this category to meet this specific ASTM standard. And then if you as a brand want to sell to Walmart, you have to follow their requirements. Same thing can happen from the government. So the federal or Canadian motor vehicle safety standards can reference back to an ASTM standard to say, hey, in this situation, we want you to reference this existing standard. I thought, interestingly, in the US, I was a political science undergrad, so a little bit of a government nerd. We have something called the National Technology Transfer and Advancement Act, which requires our federal government to use these privately developed consensus standards whenever possible. So recognizing that maybe our legislative branch may not be subject matter experts in everything that they want to potentially regulate, this gives them an opportunity with an organization like ASTM that's creating these consensus-based standards from subject matter experts to go back to essentially the experts and have basis for what they're going to then require. The Consumer Product Safety Commission in the United States is also an independent agency whose responsibility is to protect the public from an unreasonable risk of injury or death associated with the risk of consumer products. So generally in car seat world, most of our regulations fall up under the motor vehicle safety standards because we are a product that is used in a motor vehicle. However, there is one car seat category that is generally also not used in a motor vehicle, and those would be our infant carriers because they're generally also designed to be used with a stroller system. So, and they're designed to just be carried outside of the vehicle. So from a carrying the product and a use on the stroller, they fall up under the Consumer Product Safety Commission in the United States as well, which then references back to some ASTM standards that we have to follow. This is one of those ASTM standards, F2050, really engaging name there. This is required for infant carriers. So again, that webbing stuff that we just talked about and the buckle stuff that comes in the motor vehicle safety standards, that is required. We must do it. In this case, this ASTM requirement that in the United States comes from the Consumer Product Safety Commission. This is also required, but only for infant carriers. So it's only required in that one small category of car seats. Anything else, we could choose to use any of this for other car seats, and we do use this. So there's other things in here besides what I'm going to call it specifically that cover off on sharp edges and small parts and openings or places where you have moving parts that could have any scissoring or pinching, any exposed coils and springs. There's a lot of that that's required, again, for these infant carriers that we choose to apply to other car seats because we think it just makes sense. We don't want anybody to be worried about pinching or scissoring with the use of our products. Um, what's interesting to me about the requirements here under the Consumer Product Safety Commission is that we have to conduct this, or we will conduct this this testing internally, just like we do with our crash testing. But in this case, for the ASTM requirements, they have to be certified by an outside lab. So it's not self-certification on the part of the manufacturer isn't enough in this case. We have to get these components certified by an outside lab too. So some infant car seat specific parts of this is a lot of stuff related to that carry handle because again, we're thinking about use outside of the vehicle and that primary use outside of the vehicle is for this product to be a carrier and you're using a carry handle. And that carry handle needs to be robust and it needs to not pinch, scissor, etc., like cause potential injury just by the use of the carry handle. So this is a hang test testing the strength of essentially, excuse me, that hub that handle rotates around. So we have a fixture, what you see on the left-hand side. You place the infant car seat on this fixture. There's a handle that is applying pressure and attached to that infant carry handle. There's a pivot point where you can see on the left-hand side. And then there's a weight that is applied, as well as an infant dummy inserted into that car seat. So it's holding the weight of potentially a child. And what it's doing is applying pressure on the handle in a situation that we don't want you to do anyway. So I pulled a related warning from an even flow instruction manual that shows carrying this product on your hip. Now think generally, usually if I was in person, I would have an infant car seat so I could demonstrate some of this with you. But think about carrying an infant car seat, which I'm sure you have done before. And typically if you carry that and you just carry it next to you with your hand, with your arm kind of dangling down and you're just kind of holding that infant car seat handle, think about where the pressure is on that handle. It's basically at the bottom. If you can see my cursor, it's at the bottom of this handle hub. So that's where it's really, robust and it's able to withstand that weight of carrying potentially this 30-pound infant in this car seat while you're just, walking around, right? In this configuration that we're showing in this warning, where you place the product on your hip and you have your arm stretched out. I'm doing this right now. You can't see that, but I hope that you're doing this right now with me. Try to press out and against your hip. And in that situation, you're now applying pressure in this outward direction. And in applying pressure in that outward direction, that's potentially not where that handle hub has been reinforced and may not be strong enough. And why do we care? Well, we care because if you choose to do this crazy hold with your infant car seat, we want to make sure that that handle is not going to break and cause the child to fall. So that's what we're looking for. We're doing this test and we're measuring the handle in that outward direction, even though in instructions on the right, we're warning you not to do this because it's just not the way that that car seat was designed to be used. Another, we're going to warn you not to do this, but we're still going to test for it anyway, is this test on screen, which we affectionately call the anti-dump test. So this is a test, and obviously the picture I'm showing on the left is just one of our engineers sort of demonstrating what happens in this test. But this also has a fixture that is similar to that drawing that you saw on the previous page, where we're going to set up on, in this case, the infant car seat is going to be sitting kind of on a fixture that ultimately is going to be moved out from underneath it. So picture like setting it on a block. You're going to have a dummy in there, but as you can see, this isn't a real dummy. This is just a doll. But with the real dummy, we are not going to harness the child. So we are going to have them completely unharnessed, sitting in this infant carrier. We're going to attach a chain to the infant carrier handle, but the handle is going to be in an unlocked position. So it's going to be midway between a locked position and an unlocked, or like the next locked position. So somewhere between two locking positions, we're just going to place this carry handle unlocked. Then we're going to essentially kick the block underneath the infant car seat so that it is no longer being supported from underneath, and allow the infant carrier to then have the handle move to the next locked position. And the idea here is, even with that child dummy in the product with no harness on, the dummy must still be retained in the infant car seat. So this is where sometimes you find those weird handle positions that are just sort of midway between being upright or being fully behind the child's head, yet there's a position here. That position exists so that in this anti-dump test, the dummy is not dumped out of the infant car seat. It's still retained even though it's not harnessed. Obviously, we always tell you to fully harness that child at all times. So this is a misuse test that we are required to do, even though we are going to tell you always, make sure your handle is locked, make sure that child is always fully harnessed. Now, that one in particular, how many times have you been walking around the grocery store and seen some kid in an infant car seat on a grocery cart, or potentially in their stroller, not harnessed? Often. I see it a lot coming through our social media UGC that comes in. People don't understand that risk and that fall potential exists when their child is even just in that stroller. You know, they understand obviously they need to be harnessed in that vehicle, but I think the risk awareness for a lot of consumers goes down once you take that child out of the vehicle. We also, again, required for infant car seats, have to test the permanency of our labels and warnings. And I've shown just a couple of examples of labels on product. So often we have paper labels, or you might think of them as stickers. So something that we stick to that plastic shell. We have sewn on labels. So that's a fabric label that has a seam around it and has been sewn onto the soft goods. And then also on the soft goods, we, instead of stitching around the label, we can do like a heat applied label. So think about, you know, if you're doing a heat transfer vinyl with like a Cricut, you're doing something like that, but on that product. So generally, most of the language on these types of warning labels is fully required by the government. So these are things that we have to warn you about. And if we have to warn you about it, the government wants to make sure it is actually going to remain attached to that product. So for this test, there are some specific requirements around how we apply solvents to that label, potentially with that paper label, and then use essentially like a dental pick to try to pick the corner of the label and peel the label off. If we can peel off that label after we've applied all these solvents, if we can still peel it right off, that's a fail. If we can only pick, and like take off tiny little pieces of that label, then it's a pass. So we're trying to make it exceptionally difficult for that consumer to just peel those labels off a product. If that warning label, like you saw on the previous screen, is attached by a seam, so it's sewn on, we also have to attach a mechanism to that label and attempt to pull it with 15 pounds of force. Because again, we have to make sure it's sewn on strong enough that that consumer can't just rip it off the product because it's ugly and they don't want it to be there. ASTM also has something called the toy standard. So this is F963. This is obviously something that is required for toys, but a car seat is not a toy. So it's optional, and we choose to apply some of this to some of our car seat testing. And this is things like drop testing, and again, looking for small parts and sharp edges. So again, we take these things that have been developed in this consensus standard format and are able to apply it to products even when not required, because at the end of the day, we think it is the right thing to do. We certainly don't want a child exposed to a choking hazard with their car seat. So we are always checking for things like small parts and small openings where fingers, like finger entrapment situations where fingers could get stuck too. And then we have to be aware of what else is happening. So, state or provincial regulations that may impact the production of one of our products. And again, back to our flammability, that's where a lot of this comes in. That at least in the United States, there's a number of states that have been regulating the chemical exposure in children's products. And sometimes that can relate back to how we need to treat a product in order to pass the flammability requirement in vehicles. So, we're not going to ever design a car seat that can only be sold in 49 of 50 states or in 30 of 50 states. Like that just doesn't make sense. And same for Canada. You know, if we're going to sell a product in Canada, we are going to sell it all across Canada. So our team has to be aware of what these requirements are and how that can potentially impact the production and or sale of our products in a certain location. And then we have a lot of things that are just our standards that we have created over time because we feel like they are important, again, for that consumer satisfaction with the product. And a lot of these do then come from situations where we've gotten questions about this over time with our customer service team. You know, or is something we've seen throughout development of a product and have decided to add something new into the QR so that we can test for these kinds of things going forward. So again, these are even flow specific because that's the lens that I can speak from. But I think a lot of what you're going to see that I'm going to talk about are things other brands are doing too. They're not required by any specific piece of legislation or regulation. It's just things that we're doing because we want to make sure the product is going to function the way that we want that product to function. So I'm going to start with dishwashing and cup holders. So we have a number of cup holders on products that can be removable. And because they're removable, we have also tested them to be dishwasher safe. So when we say, and I would ignore where the specific models that it calls out because there's a lot more in our lineup now. But generally, if our instructions say that cup holder is removable and also dishwasher safe, it means we've done that testing. And in this case, with dishwashing, we put it through 75 cycles in the top rack of a dishwasher, just a regular old consumer dishwasher. And we run that thing 75 times because somewhere engineering has determined that 75 is the life cycle for that product. So often, you know, when we talk about life cycle testing, again, we're testing it how many times we think that consumer may do that thing in the life of that product. Similarly with fabric cleaning. So every even flow soft goods, as long as I have been with the company and even much longer, we're going on 11 years for me now. And this has been around way before I started with the company. Every one of our soft goods from institutional all the way up through our fanciest new green and gentle fabrics that we've come up with. Every one of them are fully machine washable and we test that. So we do 10 cycles in the washing machine. We also allow you to tumble dry on low heat. So we do 10 cycles in the dryer, exactly as our instructions allow. We do that for these products, and then we take them out. We put the fabric back on the car seat. So we want to, like, what we're looking for there is degradation of the fabric. Is there any issue with the material on the fabric? Are all of the seams still intact? Can you still put the soft goods on the product the way the soft goods were intended to be used, especially, you know, when allowing drying? You're not seeing any shrinkage or any areas where that fabric and the soft goods are no longer fitting the product. We have some requirements internally around the base and the infant car seat. So, number one, we, for the most part, want to make sure an infant seat connects to that base just with the weight of the infant car seat and the carrier. So, it needs to be easy enough that basically, when you have it positioned, the infant carrier just drops into the base and can connect. We also want to make sure that the incorrect infant car seat does not connect to the incorrect base. So an infant car seat is paired with a base, and those two things should work together. And if I took a different infant car seat and tried to connect it to that base, if it's not intended to work with that base, it should very obviously not allow connection. So an example from our, lineup is our Light Max, which is what you're seeing is one of our original Light Max bases on screen. And then we have a lower price point, opening price point Nurture Max infant car seat. The Nurture Max carrier cannot fit on a Light Max base. A Light Max carrier cannot fit on a Nurture Max base. They are not designed to work together, and therefore we make the design so that they really cannot attach together. And then we give you warnings and instructions that say such that you can only use this carrier with this specific base and it will not work with any other base. We do force testing for any moving components. So if it's something that you're going to be squeezing, and specifically if you're going to squeeze it on a regular basis, we want to make sure that you can use it with a reasonable amount of force. And, generally in our head, it's that like the basic comparison is it should be something that a grandmother or a person with limited hand strength that they are able to operate. So we create a baseline, and then we compare that. And sometimes, different products call for different metrics here, but we are testing things like the triggers of a carry handle. So that adjustment button that you're squeezing to be able to rotate the carry handle of an infant car seat, the mechanism for a flip foot or a recline foot, a squeeze trigger on a headrest to raise and lower the headrest. And we test this manually. So a operator is testing it using a force gauge. We do abuse testing because we know, things happen and we want to make sure, especially like thinking about the environment of a car seat, if a child is climbing onto that car seat in an attempt to get themselves in the car seat, we want to make sure that it's not going to break a component of the car seat. You put that 40-pound kid climbing into their booster seat and using that armrest or grabbing onto the backrest as they're trying to do that, we want to make sure that that component is not going to break. So generally for those kinds of detachable parts, like this being a high back booster that has a detachable high back portion, we're going to attach a 50-pound load and pull in every direction to make sure that reasonably that child isn't just going to break that component. We're also, this is oh, I thought the video was going to run. Here we go. Oh, okay, there we go. I was like, oh, if my video didn't run. So this is another type of force testing that we're doing. But again, an abuse test. Think about this scenario with this backless booster, a child climbing in and out, and specifically this one where the pressure like down on that armrest. If that child is climbing into the booster seat and then grabbing those armrests to push themselves back into position, we want to make sure that the armrests are strong enough to be able to do this. So we're loading that armrest with pressure both downward from that child scooting their bottom back, but also this outward pressure that you can see being applied to the handle in this video. One of my favorite tests is this contamination testing, and this is because we know kids are going to make a mess in that car seat at some point. There is going to be gross, there is going to be yuck. Any family that says that child never ever eats anything in the car, that's probably a bit of a stretch. At some point, they've probably eaten or spilled or had some other bodily situation happen and stuff has gotten into the car seat. So we want to make sure that mechanisms are going to perform even when contaminated by different liquids. So we do have a very specific test here. So we take equal parts of whole milk, baby formula, soda, apple juice, and grape juice. We mix it together and we pour it into whatever mechanism it is that we're testing. We leave it for 48 hours and then we test to see if that mechanism still operates as intended. So this, when I originally created this presentation a number of years ago, I thought, gosh, this seems like fun for my then 5-year-old kindergartner to work on with me. So we did. And obviously, this is not in a lab. So this is done in a little bit more formal setting in the lab. This was just our at-home science experiment, but we added all of those ingredients together exactly as specified. I had access to many buckles, so we poured it over a buckle, let it sit there for 48 hours, and then we were able to pop those buckle tongues out as you see 48 hours later. So a fun little experiment, but obviously we understand these kinds of things are going to happen in that car seat. So that's part of what product integrity testing is looking at, are some of these misuse or other, just general life situations to make sure that product can handle it. We also do temperature testing. Products are going to live in hot and cold throughout the year. So we want to make sure that when they are exposed to those vehicle temperature environments, that product will still perform. So we'll take the car seat, we alternate between a freezing temperature, room temperature, heat, room temperature for 24 hours, and then we do drop testing on all the major sides. We also do a lot of packaging testing, and this is something that I've always just been fascinated in, that the amount of effort that we put into just that carton that is shipping that car seat to you, I think is pretty wild. We, in fact, have an engineer whose sole job is packaging. This is all he works on, is how do we get the product in the box, in the right size box, and ensure that when it gets to that consumer, that the box has done what it needed to do. So we have lots of different tests that we do, simulating that packaging, shipping, storage kind of environment. One of those is this. This is an overground transportation test. So it's simulating the box gets placed on this vibrating table, which is designed to simulate that transport in a semi truck, essentially. And we're looking to see if there's any abrasion on the soft goods, if there's any damage to labels on the product, certainly if there's any plastic components that are damaged. So we vibrate the product in that box for an hour on each of the box faces. Then we will also do some drop testing on different corners of that box after they've been traveled. So, you figure FedEx has it in the back of their truck for a while, and then they're taking it to your front door and they drop it. What's going to happen then? So that's kind of the stuff that we're testing for here. And this also then gives information, because when we are working through manufacturing and when they're actually building these products on the line and then placing it in the box, they have to be oriented in the box in exactly the way our packaging engineer says they have to be oriented. And that has to do with all of this testing that we're doing. So he's going to figure out, like, oh, on this face, we see some abrasion with these soft goods and we're having a little bit of a rubbing issue here. So either maybe he needs to add in some additional packaging, or we need to reorient how that car seat is being positioned in the box. We're also doing this testing thinking about how it's going to be stored before it ever goes out to that consumer. So we store it in our own facility, which is climate controlled, and then we're going to ship it out to a retailer who probably has a climate controlled facility too, but at some point it might end up in a place that isn't as climate controlled, and it's going to sit in storage before it goes out the door. So we test all of our car seats in the box in cold environments, so frozen for 24 hours, and then we drop test them while frozen in the carton. We heat it to 130 degrees for 48 hours and then drop test in the carton. And then we also apply humidity and heat at 90 degrees and 90% humidity for 24 hours to make sure, again, that all components are still functional, that labels are still legible and attached to the product, etc. And then when we have specific components that we've designed, we design new QRs around those components. So this is a bit of an older reference, but this goes back to our Sherlatch connectors, which were self-retracting lower anchors. We also had a lower anchor system that was a ratcheting lower anchor system. So we've designed both of those. They are even flow design patents. It's something that our team developed and created, but they're manufactured by a third party. So we're not manufacturing them ourselves. It's being manufactured by another company who's doing their own testing as an outside vendor. But then we would again test every one of those components in our factory against our own test spec before they would be applied to a product on the manufacturing line. So when we design things that are a little bit different, we're going to create new quality specs as a result. Sensor Safe is another really good example of that. And Sensor Safe gets even more involved and complex. And I'd add our sensory soothe handle to this too. I think I'm feeling the need to redo this presentation in the next year because adding in these technical components adds a lot of additional technical complexity to the product. So we're also required to meet other regulatory things, like in this case FCC. There's certifications that we have to meet with Sensor Safe because of that Bluetooth compatibility. We're doing battery life testing to make sure we don't want to have a battery that the consumer has to replace over and over and over again, because that's going to be detrimental to consumer satisfaction. So we have to create these other test protocols to align with however these new innovations are going to work and engage with that consumer and with their environment. So, just to wrap this up on some curbside messaging, because we just spent, almost an hour talking about really nitty-gritty details. What of this do I hope that you will take away and think about the next time you're working with a family? So I hope that this provides a little bit of help to you in responding to some of the common questions I know that I see. One of those questions, why can't I just add whatever new gadget to this car seat? I think always our default answer is, oh, well, that, manufacturers never crash tested with that product. But I think that this, I hope, gives you a little bit more, that it's not just about the crash testing, which is obviously important, but there's a lot of other stuff that we're doing. So if it's a piece of soft goods, that other thing has never gone through flammability testing before. So we don't know what would happen to it if it's exposed to fire. Those are the kinds of things that we're testing for in product integrity. So it's more than just the crash test. My favorite is, look at this box. We see those on social all the time. The box is beat up to pieces by the time it ends up at the front door of that consumer. I am telling you, the amount of testing we do at that box, it's wild. So, generally, if the box is a mess, it's probably done its job. And as long as that car seat does not appear damaged in any way, then that box did what it needed to do to get that car seat from point A to point B. I also love when somebody wants to know if they've dropped their car seat, because it's going to happen. You're moving that car seat. Our previous house up in Tennessee, we had like 5 steps that you had to walk to get from the house into the garage. So if I'm taking something in the house from the front door and then going down to my garage, maybe you trip, maybe it falls out of your hands while you're just going down a few steps. That's going to happen. We do a lot of drop testing to make sure in different situations that might come up, that the product isn't just going to crack apart. So again, as long as you inspect the product and you don't see any damage, it's probably just fine. I hope this gives you a deeper understanding of all of the work that goes into manufacturing and testing our products. Again, it is much more than just crash testing. All of these individual components are tested really thoroughly to confirm their performance. That full car seat package is thoroughly tested prior to and throughout our production. And then even that packaging, that's always just been so fascinating to me, the amount of time and effort that we put into just that packaging to get that product safely from our factory to wherever it is headed as its final destination. But always, when in doubt, contact us. We are here to help answer your questions. We are here to help provide guidance. Certainly, determining if that product is indeed safe to use is outside the scope of our certification. So if you have questions, you want to have more information, or you're just not you're just not sure, because that product box really does look like a hot mess when it shows up to that consumer, just call customer service, because put that liability back on us. Let us determine if that product is indeed still okay to use. It is always okay to ask those questions. That's what we are here for. This is my contact information, so you can always get back in touch with me. Ian is no longer with the company, so apologies that I did not remove his email address from this, but he was the product integrity engineer who worked on this presentation with me. So we have a number of engineers, quality engineers. This is their life. This is what they do all the time, is make sure these products can do what they need to do for you. So with that, thank you. Sorry again that I cannot be up there with you. I really hope that I can get to Canada next year. It would be so great to see you all in person, and I'm happy to answer any questions. Feel free to always send those my way. I'm happy to help with whatever I can. Hope you have a great rest of your conference. Thanks.